So Mrs. Steffen told me that you guys are doing a really fun activity where you guys are bringing in snacks and you are trying to find out what the best snack is. And the best way to do that is to make brackets where they will go head to head and the winner moves on. And so you will be at the end, you will find the ultimate best snack. So when she told me this, I said there's actually some really cool math with brackets. And the one that I think is the most interesting is how many different brackets you can fill out. And with that, you can kind of find what's the probability of finding the perfect bracket. What's the likelihood that when you fill out a bracket, you will get every single pick right. So 16 is kind of a lot. So it's easier to look at a smaller sample space. So rather than doing 16 teams, I broke it down to do A, B, C, and D. And 16 snacks. Sorry, I shouldn't say teams. A lot of times people think of sports tournaments, and so that's when they think of teams. So the bracket we're using, A, B, just an example, and we're going to find a pattern that we can use to then help us out find the answers to the bigger ones without doing all the work. So first, we're going to look at just these first two games. So these first two games, we're going to look at the number of outcomes we have. So the number of outcomes between A and B, well, either A can win or B can win. There are two outcomes. That's it. Same thing with the next one. It's either C or D. There are two outcomes. So I'm going to make a list of what these outcomes could be. So for the first outcome, we could have A wins the first one and C wins the second one, so they play each other in that third game. Well, we could also have A and then D against each other. Well, what if B wins the first one? So we have B wins the first one, C wins the second one, so they play each other, or B wins the first one, D plays the second one. So how many outcomes are there? There is 1, 2, 3, 4. We have two outcomes here and two outcomes here, and this is where you can use one of the math things that you guys just learned is exponents. So 2, and we have 2 of those, so we raise that to the second power. That gives us the total number of outcomes we got was 4. So if we go one step further and we add this extra, so we had A, C, A, D, B, C, B, D. Each one of these outcomes also going to have another outcome. So out of A and C, when they play each other in this third game right here, it's either going to be A wins or C wins. And out of AD, either A wins or D wins. Out of BC, either B wins or C wins. And out of BD, either B wins or D wins. So now, how many options do we have? ACA is an option, so that's 1. ACC is an option, so that's 2. So we have 3, 4, 5, 6, 7, and 8, which is really interesting because this has 2 outcomes. This one has 2 outcomes, and this one has 2 outcomes. So there are 1, 2, 3 different places with 2 outcomes. So 2 raised to the third is indeed 8. So that is the key that we're going to use to find out the number of possibilities that we have in some of these bigger ones. Now, one other thing that I actually didn't know until I started doing this activity, and I'm sure it can go into more depth than I'm going to, well, it does go into more depth because I have to do some more research and some more examples. But if there are 4 teams that play in the tournament, then there are 3 games that are going to be played throughout the whole tournament. And it's always 1 less than the number of teams, which I'm sure there is a math philosophy or a math proof of that, but I am unaware of it. But it's true. That's what I learned. So let's go on to the one that you guys have. So I have this bracket. Again, they play each other and keep moving on until they have a winner, which, again, what we just learned, if there are 16 teams, there's actually 15 games that are played before you get that winner. So how many outcomes are there? Well, again, each one of these, we have 2 outcomes. So we have 1, 2, 3, 4, 5, 6, 7, 8, which, again, we're eventually going to get to 15. About that. So we're eventually going to get to 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 spots where you have 2 outcomes. We have 2 different teams. One's going to win. So that's 2 to the 15th. If you put the calculator, 2 raised to the 15th is 32,768. 32,768. So that's how many different outcomes you will have. So what's the probability that today, when you choose your snacks, you choose a perfect bracket where every single one of them you get right all the way up into the winner? Well, there's only one perfect bracket that you can pick if you get all of them right, and there are a total of 32,768. So if you want to look at what that is at a percentage, 32,768. That is 0, 0, and we have 1, 2, 3, 4, 5%. Oh. Yeah. Roughly like that. I mean, I'm sure I maybe put in an extra 0 or forgot a 0, but that's the concept. It's very, very small. So that's the number of perfect outcomes you can have. And again, if you want to list them all out, you can. It would just take a while because there's 32,000 of them. Which brings us into if you have the NCAA. So this is, people talk about the brackets, and you've maybe heard this, but just in case you haven't heard this, or if you have heard it, now you know how they found this. There are 64 teams that participate in the brackets, which means, as I said, that means there's 63 games that are played. So again, each outcome, there are 2 different teams that play. So you have 2 options for every single step in your bracket. So 2 raised to the 63. So let's go back to my calculator. 2 raised to the 63 is 9.22337204 times 10 to the 18th. 9.22 something 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 times 10 to the 18th. Now, one thing you guys haven't learned yet, but this times 10 to the 18th is called scientific method. And what it really is, just to give you a brief overview, is that number is so big that it doesn't fit in your calculator. And it's really hard to wrap your mind a number that's that big. And so in science, a lot of times they use this notation to make it a little bit easier to grasp how big that number is or how small that number is. So this is the answer I got, which ends 10 to the 18th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I moved that decimal over 18 spots, and that is roughly how many different brackets you can fill out in the NCAA brackets. Which, if you want to round a little bit, actually, so they rounded, because again, your calculator doesn't fit this, and so they rounded this. That is the actual number, and that is roughly 9 quintillion or 9.2 quintillion. So sometimes you like to ask yourself, how come there's nobody that gets a perfect bracket? You never hear about anybody that has a perfect bracket in the NCAA. I've also heard of like ESPN offering like $1 million prize or something if you get a perfect one, and it's because your probability of guessing a perfect bracket is 1 out of 9.2 quintillion. So it's a very, very, very small percentage. Now there are some other factors in there where obviously if a number 1 team is playing a number 16 team, it's more likely that the number 1 team plays or the number 1 team wins. But that said, there are upsets all the time, and so when they look at the probability and the statistics, they always look for those 2 outcomes. So I just thought that would make this a little bit more interesting, where it's you can see how big this happens and how big these numbers get. So you know that there are a lot of different brackets you can get. So good luck filling out your perfect bracket, and I hope you the best. And treat your teacher really well. That'd be greatly appreciated.